In this video, we are going to do a number of examples on probability, including with complements and a gumball type problem that may be useful for the graded portion of today's homework. So let's get started. If we start with two fair coins, meaning each of them is equally likely to give us heads or tails, we're flipping two of them. So our sample space would be heads and tails from the first die, or coin, heads or tails from the second one. And so all in all, we would have either heads, 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 tails, tails, heads, or tails, tails. So the size of our sample space is equal to 4. So the event of flipping one heads and one tails, well, either we have heads, tails, or tails, heads. So our size of the event space is 2. So the probability of getting one heads and one tails is 2 over 4, or 1/2. However, as a fun counterpoint, if we instead wanted to look at getting two heads, 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 for example, then the size of our event space would now just be 1. So our probability of getting heads, heads would be 1 over 4. So it's twice as likely for us to get one heads and one tails as it is for us to get two heads. And some people find that surprising, but mathematically, it all works out. So two four-sided dice are rolled and their numbers are multiplied. So we have 1, 2, 3, 4 from our first dice, our first die. 1, 2, 3, 4 from our second. And so when we multiply, we have 1, 2, 3, 4, 2, 4, 6, 8, 3, 6, 9, 12, and then 4, 8, 12, 16. So the size of our sample space is 16, not because the last number is 16, but because 4 by 4 gave us 16 possible outcomes. Again, notice that some of them appear more than once. So then the product being less than 5, well, we could have 1, 2, 3, or 4. So this entire first row. From the second row, we could have 2 or 4. From the third row, just 3, and the fourth row, just 4. You don't have to write it like this. I'm just showing visually where they come from on the table. And so the size of this sample space is 1, 2, 3, 4, 5, 6, 7, 8. And so the probability that our product will be less than 5 is, I just noticed I did something incorrectly. The size of our event space is 8. There we go. Now, when we calculate the probability of getting a product less than 5, it's 8 over 16, or exactly 1 over 2, which we could also express as 50%. Which also means we have a 50% chance that we get a number greater than or equal to 5. Let's do a couple more examples like these. So let's assume we pick a random day in December. How many days are in December? Well, the size of the sample space is 31. And then the event is getting Christmas Eve or Christmas Day. Well, these are just two of our possible outcomes. So the sample space is 2. So the probability of randomly selecting a day in December and getting Christmas Day or Christmas Eve would be 2 out of 31. This isn't going to give us a nice decimal or a nice percent. So instead, we can just leave it as a fraction. Here we go. All right, so more with dice. A 3-sided die is rolled and a month of the year is chosen. So we could have from the die 1, 2, or 3. And then for the month, well, we could have January, February, March, April, and so on, all the way down to December. And so the size of our sample space is going to be 3 times 12, 3 for the number on the dice, 12 for the number of months. So the sample space has a size of 36. Getting an even number or a summer month. So there's only one option of an even number. So the number of even is equal to 12. The number of summer, well, there are in total 3 summer months, but for each summer month, it's times 3 that it appears in the table. So that would be 9. But we have to be careful because there are some combinations that are both even and a summer month. And so we have to make sure to get rid of those. In particular, we have to subtract the number of even and summer. In particular, there's 3 of these. I guess that would be August. August begins, or is it June? June begins summer. So June, July, and August are the 3 summer months. And so that the combination of June and 2, July and 2, August and 2 are being double counted. So we have to remove these. So what we end up with is 12 plus 9 minus 3. This is going to be equal to 12 plus 6. So the size of our event space is 18. And so the probability that we randomly roll an even number or a month in the summer is 18 over 36, which also reduces to 1/2. It might be surprising that the probability is so high, but as it turns out, it is. Probability is an incredibly powerful tool, and understanding it will help you avoid so many types of misinformation. Statistics especially can be a great class to take just because we are all bombarded by data in newspapers, in books, in our workplaces, people trying to sell us stuff. And so understanding probability and understanding statistics makes you a much more informed consumer. So your money goes to better places, but also a more informed person and citizen. So you're able to really contribute much better to the community around you. Here's a couple more examples on complements. So the probability of an event's complement is 3 over 7. So the probability of the complement is 3/7. So what this means is the probability of the event, just calling it A, is equal to 1 minus 3/7, which is equal to 4/7. Remembering that the probability of something and its complement always adds up to 1 is a really powerful tool. For this second example, we are told that the probability a sports event ends in draw is 1 in 20. What's the probability the event ends in one team winning? Well, if one team wins, that means the other team loses. So this and getting a draw are in fact complements. So if the probability of a draw is 1 in 20, the probability of a win for one of the two teams would have to be 19/20, which I think as a percent, is that 95%? I believe so. If it's not, someone will tell me. That's how the internet works. Lastly, we're going to do a probability with a gumball machine. So a gumball machine contains 10 red gumballs, 8 blue gumballs, 3 green gumballs, 5 purple gumballs, and 12 orange gumballs. Obviously, this is not the one that's pictured. This one has too many gumballs in it. So we put a quarter into the machine and we slowly turn the lever, and we want to find the probability of each event. So the first thing we need to know is the size of our sample space, which is how many gumballs are in the machine. So what is the total? So using a trusty calculator, 10 plus 8 plus 3 plus 5 plus 12 gives us 38. So the total sample space in this gumball machine is 38. And because the power of computers is so wonderful, I can add right here that the total is 38, and then I can change the color to match what we had above. So the probability of getting a blue gumball, well, there are 8 blues and there are 38 in total. So it would be 8/38, or I believe it is 4/17 when we reduce this. Or is it 19? When in doubt, go to your calculator. 38 divided by 2 is 19. And then I shouldn't write 8 again because I'm reducing the fraction. 4/19. Getting a red or green gumball, well, we have to add 10 reds plus how many greens? 3, all over the total amount, gives us a total of 13/38. Now, notice that there aren't any gumballs that are both red and green in this particular problem. So we don't have to worry about the case where any of them get double counted. Not getting a purple gumball because fake grape flavor is gross, I feel. I, of course, respect if you happen to like fake grape flavor, but I don't think I ever will. So we are told that there are 5 purple gumballs. This time we want the complement, or we could just subtract the 5 from the total. So 38 minus 5 is going to be 33. So 33/38. So getting a yellow gumball because lemon is good. Except there aren't any yellow gumballs. So the probability is 0/38, or just 0%. It is impossible to get something that isn't there, alas. And lastly, getting an orange gumball and then getting a green gumball. So the orange gumball, we have 12 over 38. And then the green, well, there are 3 green gumballs, but we have to be careful because we've already taken an orange gumball out. So there's 38 minus 1 inside the machine. So that's 3 over 37. Now, each time we put in a new quarter, that's like making a new decision. And these two decisions happening separately are independent. So to find the probability that both of these things happen, we need to multiply 12 over 38 times 3 over 37. So 12 times 13 is 156. 38 times 37 is 14,000. Hold on, what's going on? That was very strange. 38 times 37 is 1406. I can see if this will reduce on my calculator. So 156 divided by 1406. It does reduce to 78 over 703. And this is approximately, if I convert this to a decimal, this is approximately 0.11, which would be 11%. So there's a slightly better than 1 in 10 chance that if we put in 2 quarters, we'll get an orange and then a green. Something for you to wonder about, would it be the same probability of getting a green gumball and then an orange one? Let me know in the comments, at least for now. That's it for this video, and definitely that is it for this lesson. Have a great day.